Hello, this is Gregory. Today we will try to adjust driving because of some random or systematic deviations. So the robot would be able to correct its direction. So let's make my block, and it will called adjust forward. It will be adjusting direction, and it will have two inputs: direction and speed. In direction, that will be rotation, the gyro that you need to go to. So the idea under this correction is first the robot needs to sense the error, and the error will be the difference between rotation of the brain and direction you want to go. If it's same, there is no error, and if they're different, there is an error. So you need to make a variable error, and set it to this value. So now the robot knows the deviation, what it's going to do. So if the robot is going forward and it's deviating to the right, let's see. If it's deviating to the right, how does it need to correct it? It needs to turn left. So it needs to add speed to the right wheels and reduce speed from the left wheels. And that's exactly what it's doing. It takes speed and reduces the error. But instead of error, we need to correct it because the response to the error might be too strong or too weak. So we multiply it by a coefficient. And those coefficients should be defined at the beginning of the program. And then, just like we did before, we adjust the whole speed a little bit to correct for different wheels and imperfectness of the robot. If this coefficient is 1, it does nothing. And if it's slower, you need to, for instance, in my robot, you need to slow the left wheel a little bit. Okay. So when you run the program, you need to calibrate the brain internal, and you need to define the variable. You need to take KF, means for forward, and set it. For my robot, 2 or 3 was the experimentally found good coefficient. And of course, you need to set the original rotation to 0. Set the brain field rotation to 0 degrees. All right. So what the adjust program does, it alters velocity to the speeds. So if the error is large, the difference in the speed will be larger and the robot will return stronger. If there is slight difference, it will return slight. And then it executes our subprogram drive, which means just spin the left wheel and spin the right wheel forward. A slight modification of this program is adjust forward 1. It does the same thing, but it doesn't drive. So you have more flexibility of using the program. There are 2 ways of using it. You set this velocity and then you spin them. Or first you can spin them, and then while they're spinning, you are doing those velocity. When you do backwards, it's exactly the same approach, but you're just spinning wheels in the opposite direction. So now let's try to use adjust backwards, reverse under a condition. So when it starts to go, you don't want it to go indefinitely. And the first condition is a sensor. My robot has a bumper sensor on the back, so let's program it to go backwards until the bumper hits the wall, and then it will stop. So now let's use program adjust backwards. So we'll need to use control loop until. So it will go until the bumper is pressed. Just repeat until the bumper is pressed. We'll put it here. We need to go to bumper sensing. Bumper sensing. Bumper is pressed. If it's true, it will execute the adjust driving program. And then it will go adjust backwards. And for the backwards, well, we'll also need coefficient, and we'll just use a different one for flexibility. But for my robot, it's usually free. It works both ways fine. Let's set the reverse coefficient to 3. And let's do adjust backwards. In my block. We go straight backwards, so the front will be still facing the 0 direction. So the rotation will be 0, and speed, let's do 50, and see how it runs. And the program will be activated by the controller button R up pressed. Now let's look at the robot, and let's look at the console for the brain rotation. First, we need to turn it around so the back will go to the wall. Okay, now let's run it. So you see, I kicked the robot, and it returned back to the direction. And then it hit the wall and stopped. So that's how it's working. And a very good illustration how the robot is returning to the direction when it's kicked. In the next video, I'll show you how to make the robot drive straight to a certain distance, and how to navigate without any turns.